So today we're going to be discussing sleep sort, which is a sorting algorithm that has often been referred to as the laziest of sorting algorithms. So how does it work? Let's go ahead and discuss it using an input example. So say I have an array of integers with 2, with 8, and with, say, 6. So what we're going to do is we're going to come across, we're going to see 2, we're going to create a thread for that and sleep it for 2 seconds. Then we're going to see 8, sleep that for 8 seconds. And then we're going to see 6, sleep that for 6 seconds. And in each thread, after we're done sleeping, we're going to go ahead and print that number out. So let's go ahead and work on implementing this. So first thing I'm going to do is I'm going to create my sleep sort method. So I'm going to get a public method. It's going to be static, and it's not going to return anything. For the purpose of this, we're just going to be printing it out in a sorted order. We're not going to be returning a sorted array. So let's call it sleep sort. And let's take in an integer array we're going to call nums. So what we're going to do here is we're going to iterate through this. So let's go I is less than nums dot length, and let's iterate I. And okay, so actually before we do anything for each of our numbers here, we're going to need to work with threads. And so full disclaimer, I'm not too experienced with threads in Java, as I'm sure you'll soon see. I kind of just looked at the Java doc for threads for a few minutes and then took what I learned there to go ahead and implement this algorithm. So the way I'm going to implement it, and I'm sure there's multiple ways, but the way I'm going to do it is I'm going to create a nested class, a static inner class, that's going to implement our runnable interface. So that's kind of a nice thing about sleep sort, to be honest, is it helps teach you a little bit about threads if you don't have much experience there. So we're going to implement our runnable interface, which is one of the ways we can create threads. And then I'm going to give it a member attribute I'm going to call val. That's just going to be whatever number I'm sleeping for. And I'm going to go ahead and create our constructor that takes in a value, and it's just going to set the val to equal whatever was passed in. Okay, now the fun stuff. Now we're going to go ahead and override our run method. This is going to do really all the work of our sleep sort algorithm. So it's not going to return anything. It's just called run. And the first thing, we need a try catch block here. Reason being, we need to catch an interrupted exception in case anything happens with the thread. So I'm going to go ahead and sleep whatever thread we're on. And one more note, sleep takes in a millisecond precision. With sleep sort, if we're sleeping a ton of numbers, we run the risk of a number printing out its value before we got the chance to sleep all the rest of our numbers, and it would produce inaccurate results. So in order to reduce that likelihood, we're going to go ahead and multiply our number by 1,000. So it's really going to be sleeping for a duration of seconds here instead of milliseconds. So let's multiply 1,000 times the value. And then after we're done sleeping, we could go ahead and print out that value. Okay, so go ahead and print it out. Now we got to catch this exception, and we're catching here an interrupted exception. And for the purpose of this, let's just throw a new runtime exception. Okay, so that looks good to me. Let's go ahead and go back to our main sleep sort method. So where we left off, we were iterating through our integer array. And what we want to do now is we can instantiate a sleep sort run. And we're going to call that sleeper. And let's do new sleep sort run and pass in whatever current number we want to sleep. Our work isn't quite done yet. We've created a new instance of sleep sort run, but we haven't created that new thread to then sleep. So let's go ahead and create a new thread. give it our runnable, which in this case is our sleep sort run, and let's go ahead and start it off. That's going to kick off the sleep and then the print. So that looks good to me. Now what we can do is go ahead and implement our main method so we can test this and see it in action. So let's go ahead and create our main. Okay. So we're going to call that Nooms as well. I'll come back to this in 1 second. And then we're going to call sleep sort on whatever we pass in there. Okay, so what values should we use? To start off, let's go with some smaller arrays. Let's go off with, say, a 4, a 2, and a 6. So we should expect 2, 4, 6. Let's go ahead and test that out. Hopefully this compiles. So, okay, I'll cover up that. Let's go ahead and compile it. Sweet. Okay, so it actually compiled. Let's see if it works. So there's our 2. There's our 4. And there's our 6. So that works. Let's try a couple more just to verify everything's looking okay. So let's give it a bit of a trickier one. Let's give it a 5. Let's give it a 1. Let's give it a 3. Another 1. And let's give it a 7. Okay, let's see if it's up to the task. It's gonna compile and let's run it. So we should see that 1, 1, nice. Then our 3, then our 5, then our 7. Okay, cool, it worked. Let's do one last one just to make sure everything works. So let's do kind of a larger number here. Let's do, say, 93, 4, 5, 1. And let's do 1. So I would expect to see 1, and then I'd expect to see 93,451. So, oops, I'm not going to purchase Sublime. Okay, so we compiled it, and now let's run. There's our 1, and let's wait for 93,451. Okay, just for argument's sake, let's just see how long we're going to have to wait here. So 93,451 seconds is, okay, it's a lot of minutes. Let's just see how many hours that is, though. Okay, that's almost 26 hours. So I don't know if YouTube allows you to upload 26-hour videos. So let's just pretend 93,451. Okay, cool, it finished. That was Sleep Sort. Please leave a comment if you have any questions or if I messed anything up. Thank you. Please come again.